You've probably heard the term API before, or maybe web services, but what are these things and why would you want your web application to have one? In this lesson, I'm going to explain what an API is and provide some examples of existing APIs that you might be familiar with. Then, we'll look at some of the reasons why you might want to add an API to your Drupal site and the types of problems that you can solve by doing so. Finally, we'll talk a little bit about the things that make Drupal an ideal candidate for building an API to share your structured data with the world. By the end of this lesson, you should be able to explain what an API is, why you want to create one, and why Drupal is a great fit for web services. The primary goal in this presentation is to demystify some of the terminology that we'll be using throughout the rest of this series. Terms like web services and API. So that when I say them in future lessons, we're all on the same page. In addition to that, I'd also like us to have a better understanding of what exactly it is that the services module in Drupal is going to be doing for us. So to start, let's define what web services mean. The W3C defines web services as a software system designed to support interoperable machine-to-machine interaction over a network. I think in human speak, what that means is web services is a documented and defined way for two computers to interact with one another while connected to the internet. Though it doesn't necessarily need to be a computer in the sense of a desktop or a laptop, an internet-connected device could be anything like a Fitbit tracker or, as the saying goes, your internet fridge. Web services allow those things to interact with one another in a machine sort of compatible format. In this series, we're going to be building a web service that allows any client to interact with our Drupal site and the data contained within. API, we often hear the term web services API or just web service. For the most part in this series, they're kind of interchangeable. What it refers to is the system that we're building that will allow some arbitrary client or piece of code to talk to our Drupal-powered site. The acronym API stands for Application Programmer Interface. And APIs, essentially they specify how different pieces of software, different components should interact with one another. And APIs are all over the place. We make use of them all the time. Pretty much anytime we sit down at our computer and do anything, we're making use of one API or another. And an example of an API that maybe isn't so obvious would be whenever you copy some text from one application and you paste it into another application. The API there, that copy and paste API, is sort of a system level thing that any application or client running on your machine can interact with. It can tell that API by following the set of documented protocols, hey, I've got some text that I'd like you to store in the clipboard. And then later on, in a different application, when you hit paste, that application can ask the clipboard API and say, do you have any text in the buffer that I can paste? Things like that make it easy for programs or things written in code to talk to one another without human interaction. Another common way of thinking of APIs is a standardized and documented way to access and interact with your application's content and features. What you see here is a page of documentation from the Twitter API. And it's showing the way that any third-party application with the appropriate permission could access a Twitter status update, meaning that it's possible for me, as an independent developer that doesn't work for Twitter, to access the full content of one of my Twitter updates and make use of it in any way that I want to. Honestly, I think the term documented here is also really important and often overlooked when it comes to APIs. In my opinion, an API without documentation is kind of a terrible API because as a developer, if I can't read your code, since I maybe don't even work for your company or I'm, just don't have access to the source code, and there's no documentation for your API, there's really no way for me to know how to interact with it or what's going on. So I would say that any API is only as good as its documentation, and documentation is key. So that brings us to the services module. When you take web services and API and put all of that together, that's really where this module gets its name, services. It's all about creating web services using Drupal, or exposing Drupal's data and internal actions to other applications via an API. The services module understands Drupal and Drupal's internals and how it works. It knows what a node is, it knows what a user is, and it knows how to retrieve those pieces of information. And then in addition to that, it knows how to represent those pieces of information in a sort of structured data way. So it can return them as JSON or XML or whatever we've got configured, depending on what the client requests. And then these structured data, like JSON, for example, is something that programming language can make sense of. The services module is a really great tool for making web APIs with Drupal because it's pluggable. It doesn't assume anything about what type of API you're going to want to build. You could build a REST-based service. You could build a SOAP-based service. You could build an XML RPC-based service. It provides the underlying framework for doing any of those. It's also really extensible too. It provides resources or interaction for cores, data, and actions, but it's really easy to extend it and add your own resources to the web services. So if my custom module or custom entity type needs to be accessible via API, it's really easy for me to write the code to do that with the services module. And finally, it's just a really popular solution right now. And with Drupal, it's always best to be kind of using the same tools that everyone else is using, because you'll find the best documentation and the most help. So what does services do for us? The services module basically handles incoming requests from some external client and then formats and sends them a response. Your external client asks the services API for some piece of data or to perform some action via a request, saying, hey, return all of the data that makes up the user object for the user with the ID of 1. Or perform some action like save a new email address for this user or log the user in. And then the service responds with the result of that action or the data that you're requesting. The mechanics of this request and response are going to vary a little bit depending on the type of server that you're using or the service. So a REST-based service, is it a XML RPC service? Those requests and response are a little bit different, but the end result is the same. You ask Drupal to do something via services, and then Drupal responds with some output via services. What do we mean when we talk about Drupal's data and actions? If you think about the applications that we built with Drupal, you can really kind of sum it up to there's data. There's things like nodes and users and comments and lists of data, views, files, kind of all the content of our site. Services understands Drupal's data and its formatting and allows us to access that data in a variety of different formats. In addition to data like that, though, we also have actions, which is a little bit more ambiguous. An action might be something like running the code that sends an email when somebody wants to reset their password. And that kind of thing is normally reserved for PHP or modules that are tied in directly to Drupal. But with a web service, using the services module, we can actually ask Drupal to execute that code on our behalf without actually having to write the code and call the function directly. I also think it's nice to point out that Drupal is a really good platform for building web services. And I believe that because web services are all about structured data, being able to represent a piece of content as JSON or XML rather than a giant blob of text is way more useful for the client or the thing that's consuming your data. Drupal, especially Drupal 7, already stores data in structured chunks. If you think about fields in the content types, we create our content as like a title, author field, a posted date, status about whether the node is published or not, the body and description, an image field. All of those things are individual sort of chunks of data that are really easy to be serialized and sent as JSON. Versus if it was just a big static HTML blob, it would be harder for a client to make any sense of that. Imagine that you're a robot and you've been handed a bowl of ice cream and it's got 3 different flavors of ice cream in it. And your job is to do something with each of those individual scoops of ice cream. If they're all in a big bowl together and they've started to melt, it can be hard to identify what each piece or what each flavor of ice cream is, especially if they've started to melt together. Is this strawberry and vanilla, or is it strawberry vanilla? With structured data, what we end up with is instead of just a bowl of a bunch of scoops of ice cream being sent to the client, you get each individual scoop of ice cream in its own bowl with a nice clear label identifying where it came from and what type of ice cream is in the bowl. This kind of data is a lot easier for me as a developer to deal with via programming language. So what are some examples of existing APIs that you may be familiar with? Twitter, which is possibly the most popular and most used API on the web right now, allows you to interact with all of the data that Twitter collects from status updates and people's interaction with the service. This is what makes it possible for there to be this huge ecosphere of third-party applications that use Twitter. Because there's a web services API, somebody can write a tool like Buffer, which allows me to create a tweet and schedule it for later, and then it'll use the services API on that scheduled date and time to actually post the status update on my behalf. It can do all of this without any internal knowledge of how Twitter is working, just by following the API documentation. Anybody that's got a smartphone probably uses that phone on occasion to check the weather. When you're checking the weather on your phone, it's not like your phone is just, got a thermometer in it and it's saying, look, it's about to start snowing. I mean, the phone's not doing that. There's some other external service that's doing that. And your phone is connecting to that API and saying, hey, I'm located in Minneapolis, Minnesota right now. Can you give me some information about the weather here? And that information comes back as structured data, which the phone can then parse into a meaningful visual representation. Netflix API. If you've ever watched a video on your TV via Netflix, you've interacted with the Netflix API. It's all data from their web service with lots of different applications accessing it. Amazon is another common example of APIs in the wild. They're more infrastructure based a lot of times. There's an API for create me a new computer that I can run a website on when you spin up a box on EC2. There's literally thousands of examples of APIs out there. These are just a few of the big ones. So all of that put together, why do you want an API? Why should you be using the services module? What are you going to build here? Some of the common reasons that I hear people talking about when they say they want an API. Obviously, the most common is to provide access for mobile devices, native applications, internet-connected TVs, Fitbit trackers, whatever the case is, internet-connected devices that want to make use of the data stored in your web application. It all happens with an API. Another really common one that I hear a lot is digital asset management tools. For example, a company like Martha Stewart, who has hundreds or thousands of photos for all of their recipes, might have a database system or a web service that stores all of the photos with the tags and the date and copyright information and so forth, and then delivers them via an API to all of the various clients. But think about it, those clients could also be things like an application or a website, or even a print publication. You could access an API to pull in the photo at the 300 dpi resolution that you need for that particular print publication. Or what about if our business has partners that we'd like to share our information with? It's another great reason to have an API. Let me expose that data to you as structured data, JSON or XML as an API that you can request information from. I'll continue to be in charge of the data. We don't have to do things like duplicate entry. If I update the title of a video, I don't have to call you up and say, can you update the title of this video? Because we decided to change our naming scheme. There's all kinds of reasons to build APIs for your site. And I'm sure that if you've gotten this far, you've probably got a pretty good reason to build one yourself. So throughout the rest of the series, that's what we're going to be talking about doing.